Good afternoon. My name is Narasier Nicole, and I'm a computer science student at Makerere University. I'm going to be talking about the history and evolution of computers from the first generation to the fifth generation. Let's get into it. So I'm going to talk about the first generation of computers, which was from 1940 to 1956. But before I go into that, I'm going to classify the different generation of computers into these categories. I'm going to talk about the years. I'm going to talk about the technology used. I'm going to talk about how the technology was used. I'm going to talk about input and output devices, storage medium, examples of the different computers used in these different generations, and I'm going to talk about the advantages. I'm going to talk about the disadvantages, and I'm going to talk about the different people in these generations who fought for the evolution of computers up to date. So about the first generation of computers, it mainly comprised of vacuum tubes, and vacuum tubes were used for logical and arithmetic operations performed on a computer. The only problem was these vacuum tubes were expensive, bulky, and overheated, which made it difficult for human beings to use them. The different examples of computers in the first generation are ENIAC, which stands for Electronic Numerical Integrator and Computer. Then we have UNIVAC, which stands for Universal Automated Computer. Then we also have IAS. So the input-output devices used during the first generation were punch cards. And how punch cards operated was that the computer would punch holes into the punch card that represented different letters and alphabetical values that were represented in column form to represent information on the computer. Then the different storage devices used in the first generation were magnetic drums, and I think that's it for storage medium. When I did my research, that's all they brought up. And then advantages, well, vacuum tubes were the only electronic components available during those days. The computers were used to perform calculation, but in a very fast way. Then they also perform calculation in milliseconds. And I think that's it for the first generation. Before I commence, you should know that the first generation of computers used low-level languages. And low-level languages are these languages that a machine can only understand. For example, machine code. And then also, the first computer in the first generation was designed and developed by two gentlemen known as John Presper and John Markey in the early 1940s. Now to go to the second generation of computers. The second generation of computers was from 1956 to 1963, and they were made of things known as transistors. Transistors were smaller, more reliable, consumed less space, less power than the vacuum tubes, which was an improvement from the first generation of computers. Though we used to use machine code in the first generation, assembly language interpreted by assemblers was introduced later in the second generation, which was easier to understand, but of course also not completely. Then later, within the second generation of computers, high-level programming languages were introduced, such as Fortran and COBOL. So Fortran stands for Formula Translation, and COBOL stands for Common Business Oriented Language. So the input and output devices used during the second generation was still punch cards. Nothing really changed there, and we already talked about how punch cards function, but the difference is in memory storage now. In the second generation, they used stuff called magnetic core memory for data storage. And I guess there were also different advancements in faster card readers, and therefore they introduced magnetic tape readers. So now I'm going to talk about the advantages, which I noted down. So we have energy efficiency, reduced maintenance, batch processing, higher level programming languages were introduced, improved memory, increased processing speed, and etc. Then now the disadvantages: limited portability, limited memory storage, and costly because computers hadn't yet advanced to the level to which they are today. Third generation of computers, which was from 1963 to 1971, were mainly comprised of integrated circuits. Now, integrated circuits were the interconnections between gates and memory cells, of which gates were used to perform the logical and arithmetic operations on the computer, while information was read and written onto the memory cells. Obviously, in the third generation of computers, the size of the computers reduced, less heat was being produced, less power was being consumed. They were taking up less space, they were faster in processing work, there were higher programming languages introduced, such as BASIC, which stands for Beginner's All-Purpose Symbolic Instruction Code, and etc. Examples of computers in the third generation were IBM 360 and maybe IBM 370, and I think that's it. Then moving on, there were also some disadvantages in the third generation, which was they required IC chips. Air conditioning was required, which was very, very tedious and expensive, and they were hard to maintain. And that's it for the third generation. The fourth generation of computers, which was from 1971 up to date, because basically the computers from then up to now have the same characteristics, which I'm going to read later on. There was this gentleman named Moore. Now Moore had a realization that with every year the number of transistors on a single chip was doubling, and he later realized that the number of transistors was increasing every 2 years. Now, with this realization, or a law, as we call it in computer science, Moore's law, there were consequences. These consequences were that computers became smaller, more reliable, they became faster, and with the number of circuits increasing on a single chip, the interconnections between chips were reduced, therefore the processing speed also increased. So I'm going to talk about the characteristics of these computers in the fourth generation. Is that circuits are used, and there are many integrated circuits built on a single chip. And then the microprocessors are integrated with circuits, made it possible for computers to fit easily on a desk. Laptops were introduced. And examples of some of the computers in the fourth generation include DEC 10 and maybe Star 1000. But there are also certain disadvantages to the computers in the fourth generation, which is the design and manufacture of microprocessors are very complex and advanced. Advanced technology is required to produce integrated chips, because with these advancing technologies, it becomes harder to make the computers. So that's it for the fifth generation. Finally, I'm going to talk about the fifth generation of computers. The fifth generation of computers mainly focuses on computers from present day and the ones we anticipate that will be there in the future. But I'm going to mostly talk about the ones we have present day and the ones that we anticipate that will be there in the future, but minimally. So the first thing I'm going to talk about is that nowadays we have so much computerized machines that are doing human-related tasks, such as robots, such as computers that help with interior designing or planning for you to construct your next home, and all this is referred to as artificial intelligence, which is also in short form AI. Then we also have biometric devices, and these are devices that use human features for identification and authentication in security. Like, for example, instead of using a passcode on your phone, you can just put in your fingerprint, or for the iPhone's case, they use face identification or voice recognition. That's it. And for fifth generation computers, basically have the same characteristics, which I'm going to read to you, and they all include they are more efficient and very fast. They contain user-friendly graphical interfaces, and I think that's it. So the advantages is that basically nowadays human beings can just sit and relax and let computers do everything for them. And I think that's the best thing with the computers for nowadays. And in the future, we expect more computers that are going to perform in artificial intelligence. And I feel like it will reach a point whereby human beings are no longer working or doing anything, and we just have robots in place to do the work for us. And that's where we're headed. And that's how I believe that computers are going to evolve in the future. Thank you for listening. So right now I'm going to talk about the evolution of Intel times 86 and ARM architecture. But before I get into that, I'm going to briefly talk about what these are. So Intel times 86 and ARM are basically microprocessors, and they are processing families which deal with processing designs. For Intel times 86, it mainly deals with complex instruction set computers, also known as CISC, and those days was mainly used for the processor designs of mainframes and supercomputers. As for ARM, and by the way, ARM stands for Advanced Risk Machine, and the risk in ARM also has its full form, which stands for Reduced Instruction Set computers. Now, the reason for this is because its processor design mainly deals with reduced instruction set computers and embedded systems. Now to talk about the evolution of these microprocessors, but I'm going to first specifically start with Intel microprocessors. Over the years, from like 1970, these processors have kept evolving with time and time. With each decade, they keep evolving. So basically, the structure of the evolvement of these processors is from the 1970s, when we go to the 1980s, and we go to the 1990s, and then go to the processors that are evolving up to date. Though I'm going to specifically start with 1970s processors and the different versions and the different clock speeds, the bus widths, the number of transistors, the feature size, the addressable memory, etc. So starting with the 1970s, we had the processor model 4004, which was introduced in 1971, and basically it had 4 bits of bus width, then it had 2300 transistors, then the feature size was 10, and then the addressable memory was 640 bytes, which is very small. But what you're going to realize is that as these processor models kept evolving, as they kept creating new models in the 1970s, the addressable memory size kept on increasing, the number of transistors kept on increasing, which was all improvement to the processors. Therefore, they could work faster, they became smaller, they made computers smaller, and you can tell that the processor involvement in the processors really also affected the evolvement of computers up to date. So it's really crucial. Going to the next model, we have the 8008 model, which was introduced in 1972. It has 8 bits of bus width, 3500 transistors, then its feature size is 8, then addressable memory was 16 kilobytes. As you can see, the addressable memory keeps on increasing. Then we have the 8080 model, which was introduced in 1974, and it had 8 bits of bus width, 6000 transistors, feature size was 64 kilobytes. Then we move on to the 8086 model, which I'm particularly interested in because this is when you can tell the advancement was real. The 1970s was becoming strong in the involvement of processors, because this version was introduced in 1978 and it had 8 bits of bus width. Then it also had an addressable memory of, is it 1 megabyte, then its feature size was 3, then it also had 29,000 transistors. Then moving on to the next version in the 1970s, which was probably the last version created then, is the 8088 version, which was again introduced in the next year, 1979. So basically its feature size was 6, it had an addressable memory of 1 megabyte, also had 29,000 transistors. Its space, its bus width was 16 bits, and yeah, I think that's basically it for the 1970s processors. Moving on over the years, now that I'm done explaining the 1970s processors, Intel had various versions in the 1980s and the 1990s and up to date. But I'm just going to mainly talk about the main game changers in the evolution of the microprocessors, the main processors that really hit the evolution. Now that I'm done talking about 1970s processors, Intel really had various evolutions throughout the 1980s, the 1990s, up to date. But I'm not going to talk about them because the topic is vast. So I'm mainly going to hit those target areas, those target models where they really evolved, starting with the model 80,286. Now, why Intel really evolved at this point in the model is because they moved from addressable memory of 1 megabyte to 16 megabytes. Then after that model, they had the model of 80,386. Now, what's so special about this model is because this was the first 32-bit model Intel had, yes. And it was the first model that could multitask, therefore many programs could be run at once, which was new to the computer industry and the processing industry, so therefore it was a really target area. So there came the model of 80,486. Now what was so special about this model is that it had an inbuilt math coprocessor, therefore it could perform complex mathematical operations such as sine, tan x, log x, exponentials, and etc. As time moved on, well, Pentium microprocessors were introduced. Now, Pentium processors were the first Intel processors to basically perform super scalar techniques that were able to perform multiple instructions and execute them in a parallel way. And from Pentium, we had Pentium Pro, we had Pentium 2, 3, and 4. Then right after, Intel started making the cores, the Core versions. Now basically Core was the first Intel processor that had a dual core. Therefore, to imply that it had 2 cores on a single chip. And we all know that a core is a single processing unit, so therefore if they had 2 cores on a single chip, the processing was faster. And from then they've kept evolving. Then from then there was the Core 2, which had 4 chips on a single, which had 4 cores on a single chip, and therefore that meant the processing speed kept on going faster. And from then we've had different versions of the cores, currently being Core i9 13900K, which is the most recent core from Intel. And from then, after 40 years, Intel has been dominating the processor market outside of embedded systems, and it continues being the best processing family there is today.